understand? And then you divide it by itself. And then on the horizontal side, you take the horizontal distance, which is already converted into meters, and you divide it by the vertical distance. Understand? And then you get something like 1 is to 7.7. Now it's a round off. Understand? You must have one value that side and another value which is a whole number that side. Understand? Is 1 is to 8. It's converted like that. Now this is how you interpret it, meaning that if you go 1 meter vertically up, you are also going 8 meters horizontally at the same time. When I take a step up 1 meter, I'm going 8 meters horizontally. So meaning that this is quite a steep hill. Are we still together? If we are not together on the group, drop the question. I will answer you. Now, calculating the gradient, exercise 1, you just write whichever date you decide you're going to write with, and then your heading is calculating the gradient, exercise 1. Calculate and interpret gradient CE. Now, you see I've put an E there for you, so you go to the map on page 27, figure 1.26, use a pencil and put your E there and calculate the gradient. Use your exercise books, for map work for this, and then when we come back, I'll show, mark and give you corrections on this calculating gradient. Sharp. Now, vertical exaggeration. Now, exaggeration is making something bigger than is. And understand, if you make something bigger than it is, then you're exaggerating the thing. For example, if you are telling a lie and then you make that lie even bigger, already it's wrong with the lie, but you're making that lie even bigger than you should. Understand? The same goes for the truth. But in geography, vertical exaggeration, understand, is the proportion at which the vertical scale has been made larger compared to the horizontal scale. Understand? It's the proportion at which the vertical scale has been made larger compared to the horizontal scale in order to analyze the physical features meaningfully. Understand? In order to analyze the physical feature meaningfully. Meaning that if we didn't vertical exaggerate the vertical scale, then some of our land features will be flat. Understand? We wouldn't be able to analyze it. It will look like we are seeing this landscape or side view from a distance. We cannot see really what's going on. Now, to see what's going on there, we need to vertical exaggerate the vertical scale. Now, comparing the vertical scale on figure 1.29a, which is 1,000, which is 1 is to 10,000. Can you see that? And then 1.29b on page 30, same page, the scale is 1 is to 2,000. Understand? Now we are comparing these two things. Can you see that it's the same side view, but they look different? The other one looks taller than it should be. The other one looks very short. Understand? That's the effect of vertical exaggeration. Now, calculating the vertical exaggeration. Now, this is where when we tell you that 1 centimeter is equals to 100 meter comes in. That's why I do not prefer that people guess their own numbers, that I should use 1 centimeter is equals to 100 meters, because now when you're calculating the vertical exaggeration, it will give us a lot of different answers, understand, and it will be chaos when you're marking this, understand, because people now come with their opinion. This is what I did, and this is how I found the vertical exaggeration and things like that. So to avoid that, we give you the scale is 1 is to what? 1 centimeter is equals to this. Finish and clap. Understand? Now, looking at the examples there, table 1.4, page 31. Looking at those examples. Look, step 1, you convert the scale into a ratio. Now, converting the scale into a ratio we did previously when we are calculating the gradient. We did that, understand? So I'll not go into the details of that. I'll say 1 centimeters equals to 20 meters is the same ratio. Say 1 is equals to 2000. Understand? Now the vertical exaggeration VE is equals to VS divided by the HS, the horizontal scale. Understand? Is VS divided by the HS, meaning that the VS is the vertical scale divided by the horizontal scale. Now the vertical scale, as we converted there on step 1, is 1 is to 2000 divided by 1 is to 50,000. The 1 is to 50,000 come from the horizontal scale since we are using a topographical map. Understand? And then you use your calculator and then you get it's 25 times larger than the horizontal scale, meaning the vertical scale is 25 times larger than the horizontal scale for us to meaningfully see the landscape. We have to make the vertical scale 25 times larger than the horizontal scale. Yes? Any questions? Drop questions on the group. I'll make you understand if you don't understand. But these slides are so clear that I doubt there will be a lot of people who do not understand. Of course, we always have a team they'll try to make an argument out of this, but I'll answer them too. Now, calculating the vertical exaggeration, this is the second example, still on that table 1.4. We convert the scale, understand, into a ratio, but the difference now is we are using an orthophoto map instead of a topographical map. Now, the VE, vertical exaggeration, equals to the VS divided by the HS. The VS remains 1000, it remains 1 is to 2000 divided by the horizontal scale. Now, the horizontal scale is not 1 is to 50,000 because we are using an orthophoto map. Therefore, it's 1 is to 10,000. Understand? Therefore, it's 1 is to 10,000. And then we get the answer is 5 times, meaning the vertical scale is 5 times larger than the horizontal scale. That's how you interpret it. Understand? Fine. Now, activity 3, page 31, based on the topographical map. Do not do number 4. Do everything else except number 4. Important, in brackets, based on a topographical map. Understand? Because some of you will be calculating and then they use an orthophoto map, a scale which is 1 is to 10,000. Please do not use 1 is to 10,000. Use 1 is to 50,000. Now, intervisibility, page 32, figure 1.32. Now, intervisibility is just your ability to see one point from another point on the landscape. Now, looking at figure 1.31, there's a man there looking at point B. I just took the liberty to draw this on, my free hand. Understand? I'm expressing myself artistically. I can draw also. Understand? Now, look at A. The person there at A can see point B, but they cannot see point C. Understand? Okay? They can see point B, but they cannot see C. Now, A and B are intervisible. Understand? A and B are intervisible, but A and C are not intervisible. A and C are not intervisible, but A and B are intervisible. Simple concept. Now, where can the limits of intervisibility be? Now, any point where A can see, at any point where A can see, that area or that region is known as a view shed. Understand? A view shed is a point where the observer can see anywhere in that region. Understand? Anywhere where A can see is A's view shed. Understand? Where I want to know what's A's view shed, more or less around that red dotted block there. And they can see that. I know they can even see even before the ditch at sea. They can see everywhere, meaning that that's still the view shed of A. A view shed is just a region where the observer can see. Now, application of intervisibility. Now, intervisibility is applied everywhere. It's just logic. Position of cell phone towers. Obviously, if you want to get a good signal, your tower must be high enough. Understand? For almost all cell phones to pick up signal. Understand? That's part of intervisibility. Armies to set up camp. Now, if you are fighting an enemy, you need to know, you need to see the enemy coming. So your view shed must be large. Understand? Between you and your enemy, there must be intervisibility. Understand? Or at least you, in the intervisibility must be yours. You must see the enemy. Well, it doesn't matter if your enemy can see you or not. Well, but you must see your enemy. Understand? Now, placement of cameras, obviously, cameras, they use intervisibility. They need to be placed at a strategic point where they can see what's happening. It's no use where you put or place a camera where there is no intervisibility between you and your target. Understand? Yeah, with that being said, I think this is the last slide. Remember that if you do not understand, drop a question. I will answer you. Understand? Now, please respect the groups, guys, and I will send the PDF format of the presentation. I will send the video format, and if it needs be after the 16th of April about the corrections, I'll make a plan that you know what you're doing. But if you cannot wait till the 16th of April, DM me and a picture of your work, where you've written the work, and then I'll see what you're doing wrong, and then I'll answer you from there.